All right, welcome everyone. This is our last map time of this school year. Woo! Yay. We've done so many map times. I know, but I'm looking forward to a break. I'm Michelle Tobias. I work at Data Lab. I do geo stuff at Data Lab. What? I should go on the other side. Is that what Alex is doing this to me? Apparently I'm supposed to stand over here. No one spiked my stage for me, just FYI.
You set up the camera.
I just figured people could hear a disembodied voice and it'd be all right. Anyway, so I work at Data Lab, I do geo stuff, and I have Elise here who also works at Data Lab and does geo stuff among other things. And she is going to tell us today about working with Terra, because this is probably the most common question we get in office hours related to spatial R is how do I do stuff? And we have to tell them either you're doing it in Raster and that's not a good choice at this point, or please don't use Raster, please use Terra. So we have a lot of these discussions. So yeah, we planned this because we knew it was something that campus needed. So yeah, I will let Elise take it over.
Great, thank you. Yeah, this is it always only a little bit, but makes my stomach sink when I see someone come in with like an entire script full of raster code that they're trying to troubleshoot. I'm like, I'm sorry, but you do have to change because as hopefully probably you guys know, raster is going away and is I think currently archived, so you can still technically install it, but you shouldn't. Unless you're just doing it to sort of transition to Terra. So for the
can you share your screen so folks online can see it?
Oh yes.
Sorry, this is the weird hybrid room where Zoom is only sort of happening and sort of not. I didn't realize it wasn't on my other screen.
Let's see. Okay, we have to do
there you go.
Okay. Oh wait, nope. I shared the wrong one. Okay. Except you make this go away.
Yeah, if you hit the little.
Oh, that's on the bottom.
There's like on the side.
There's a minimize.
Yeah, it's kind of on the left. Way on the left of the.
People. There's like a little.
Yeah,
marker.
that little one. It's not the.
That makes it little.
Okay.
About as small as it gets, I think.
The hide thing on the other menu should make it go away. That menu you were looking at.
Oh, I've never been able to get rid of that one.
Video panel.
Oh.
Hide controls. Great.
Then you just push escape to get it back. So
Excellent.
everyone remember that.
It's been years and I never knew that.
Yeah, we're still learning Zoom stuff in Data Lab too.
Yeah.
All right, sorry for the interruption.
No problem. I'm glad that people can see now.
See, and now that tutorial is there for your.
Yeah, now people can like clip it and
Yes.
post it online. So yeah, Raster is going away. And now you should be using Terra, which is for really all intents and purposes just a 100% improvement. So that's good. So what we're gonna do, we're gonna basically talk about the general functionality of Terra as a whole. We're gonna talk about transitioning existing code from Raster and SP, etc., to Terra syntax. And I'll talk about where to find more information about this transition process and Terra in general. I will This talk is sort of designed for people who have used raster before. And so it will sort of focus on that transition. But if people have questions about, you know, geospatial R in general, I'm happy to answer them at the end. Once we get through everything else. So just as a caveat to that. Okay, so things we're going to talk about. Terra implements new classes of spatial objects. So we'll talk about those. Talk about creating those objects. There's been a lot of name changes. So we'll talk about, a lot of times it's just like, oh, you just have to, you know, use this function name instead of that function name. So we'll talk about what those are. How we deal with spatial relationships and has changed a little bit. We'll talk about doing raster calculations, which is, I would say the easy stuff is largely the same. The more complicated stuff has changed, and hopefully ways that will make it easier. We'll talk about plotting. We'll talk about what is not in Terra. So Terra, raster was a massive package and sort of included like all, you know, and the kitchen sink. And so some stuff has sort of been migrated out of Terra to elsewhere. And then we'll talk about some like under the hood functionality changes that you will need to consider with using Terra. So bird's eye view. Terra is very similar to raster. If you are comfortable with raster, I don't think you will find it that hard to transition to Terra. So that's the good news. More good news. In raster depended on SP to have vector objects. So points, lines, and polygons, those classes came from SP. And so all of the functions that sort of dealt with those were in SP. Terra has raster objects and vector objects. So you can do everything in one package if you wanted to. There's also SF, which we won't really talk about so much, and that's another option, but you can do vector calculations in Terra. Raster and SP had a sort of notoriously crazy number of classes, like separate classes for points, lines, and polygons, separate classes, you know, depending on like what, you know, how many layers your raster had or like what type of file it was read in as. So we've reduced the number of classes you have to remember. We've also reduced the number of functions. So you don't necessarily have like different functions for the same task using a different class. So like you can use, you know, it's not project raster and SP transform. There's just one function that does both for rasters and vectors. Terra is written in over 50% C++, so things are faster. And we'll, you know, see how much faster they are throughout the talk. And it's also very large. It's bigger than raster. And I already said that it is, there are some things that were in raster that are not in Terra. So there is a lot of functionality that we are not going to talk about. And I would highly recommend you go to the documentation that I'll show later to see sort of what options, what sort of additional functionality is available. Okay, classes. So there are, instead of like 7 classes, we now have 3. One for rasters, one for vectors, and one for extents. And this is regardless of whether they are points, lines, polygons, whether you have 1 layer, whether you have 20 layers. It's either it's a raster or a vector or an extent. So now we need to create these options. Because we have fewer classes, that also means we need fewer of these object creation functions. So if it's a raster, you use rast. If it's a vector, you use vect. And then we have write raster and write vector for writing data. And rast and vect, they work as like you can use those to create like a object from a file. But they also, like, if you have an SF object, you can use those to convert the SF object to a spat raster or a spat vector. I guess spat vector, they don't have raster data in SF. So it's a lot faster by an order of magnitude in some cases. Also, it's, I mean, it depends on the object, but in general, the Terra is going to be a lot faster and similar with writing. As a note, I know in some other packages, the sort of write functions are good at guessing what file type or what format you are using. Terra is not good at that. So it will oftentimes give you an error if you do not specify the file type, even if it says that it can guess what the file type is. So it's just easier to specify it and be done with it. Okay, so name changes. Some of the name changes are just seemingly for shortening reasons. So these are the big ones that at least I use on a regular basis. I'm not sure how necessary that was, but it happened. But then the thing that I think is at least more I like is that a lot of the functions got migrated, function names got migrated towards sort of similar to base R names. So instead of trying to remember raster to blank, it's as blank or is lat long is. And so you see the sort of as or is dot and then whatever you're trying to test, that is much more similar to sort of the base R syntax for function name writing, which makes things easier to guess. If you're like, I'm not entirely sure what this function name should be, there is if you can think of what it might be in base R, that's a good place to start. Also, there are a number of methods that got renamed to methods that already exist in R, like as list, like that already exists. We don't need another function that does the same thing, but just for rasters. And so that happened a couple of times with C and rbind and as list. Okay. So as I mentioned before, because Terra has both raster and vector objects, now we have one function that does the same thing for, both rasters and vectors. So projections, aggregating and disaggregating. Oh, you can't see it. Why is this going away? There we go. Okay. Aggregating and disaggregating, spatial sampling, all of these now, it doesn't matter whether you're working with a raster or a vector type object, it's the same function. And these also got a lot faster. In particular, going from rasters to vectors and back again, that like rasterized got 2 orders of magnitude faster. Spatial relationships. So previously with rgeos, which is the primary package that people use to like say, oh, do these overlap, do these intersect, g-intersect, stuff like that. there was one function for every type of relationship. In Terra, you have the function you use is determined by the number of objects you're comparing. So if it's one to many or one to one, it's is related. But if it's many to many, you use the relate function. And then the type of relationship is given by the argument relation. So, you know, there's a whole bunch of different ones. And there's, yeah. The exact definitions of all of these, I think, are available on Google. So raster calculations, raster math still works the same. You know, you can take the mean of a raster, you can take, you know, you can add, subtract, do, you know, square roots, all that kind of stuff. It's exactly the same. For more complicated calculations, there have been a number of name changes, which I will talk about. And there are also a lot more what I call apply-like functions. So functions that allow you to do a particular calculation either over an entire layer, or by cell, or by some grouping of layers or cells. And this is greatly expanded from raster. So first, again, because we are, you know, using both, you know, have both raster and vector data in Terra, we don't need different functions to calculate the areas of our rasters or vectors. And so a lot of these sort of functions where you had multiple versions of the function depending on the type of object are now just one function. Now here's the most common apply-like functions, and they have mostly been renamed to use the APP sort of I don't want to say syntax, but naming convention. And so basically the tiny names, which can people see that? The tiny names? Yeah. Those are the old ones. So those are the old names. And so basically, these are just different ways of doing calculations for each, for a set of raster. So for the app, you're drilling down through each cell. For tap, you are drilling down through each cell, but you're grouping the layers, so you'll end up with multiple values for each cell, depending on your groups. For lap, this is sort of a weird one where the input function takes multiple arguments, and each layer gives one of those arguments. So if you wanted, this would be commonly used to calculate things like NDVI, where each layer is one of the spectral wavelengths, you know, red, green, and infrared. And then global is just, I want to calculate by layer. So like, what's the average, you know, value for, you know, NDVI over a given layer, or the entire extent of the raster. I'm not going to go into this, but just suffice to say that there's way more ways to do raster calculations. And most of them, you know, any one person will probably never need, but there are, for, you know, each one, you know, you might find one of them useful. Okay, plot. So plot still behaves roughly the same. It's bare bones. It doesn't look great, but it will get you things plotted very quickly. One nice thing about it is you can specify the layer that you're plotting using the layer argument. So say you have a raster and you calculated your NDVI using, your spectral data. And then you want to plot just the NDVI. You don't have to subset that out beforehand. You can just plot it and specify the NDVI layer in the plot function. There is a panel which allows you to basically put multiple plots on a single figure, which can be helpful. And then there is also, if you are, in the ggplot world, there is Tidy Terra, which is a package that allows you to plot raster, spat rasters using ggplot. So if you're already sort of in that world and you want to add a raster, you can do that. And there's also Plet, which is basically a wrapper around leaflet that allows you to do interactive maps, but it is similarly bare bones to the sort of regular plot. Okay, so what's not included? So if you do sort of spatial data analysis and you're familiar with SPDEP and spatial reg, these are SF. So if you are, doing like nearest neighbor stuff, you will probably need to convert to an SF object, which you can do using STSSF. Also get data, which is very helpful, is now in its own package. So there's an entire package called geodata that is much better document than get data is, or get data was. And it allows you to download all the data that you could use with get data, but with more information of what's available. And also more data. So they've added, OpenStreetMap, they have marine data, they have a whole bunch of crop distribution stuff, elevation data, marine data. Okay. Now on to the sort of operational stuff. So as I mentioned before, Terra is majority C++ code, which allows you to do things like or the way it's functioned, it allows you to, not have to load in your entire data set. You can just load in a piece and then do a piece and then do a piece, which is convenient. But it also means that you sort of have to treat these objects a little bit differently. So you can't save them from session to session, which you shouldn't be doing anyway. Bad habit. Like you can't save your R data and then load it back in. You should write to a file and then load that file in. Additionally, if you work on computing clusters, you can't just sort of send that object directly to the computing cluster. You need to use a function called wrap to sort of package it up nicely for the cluster and then unwrap it when it gets there. Okay. There's a whole bunch of resources that I'm not gonna go through here. But they are available if you go to the DRUG website, GitHub/DRUG/raster_2_Terra. And that will have all of this information. It also has links to sort of script that I wrote as like an example of like going, starting with a raster script and transitioning to a Terra script. So here I would say I have a couple sort of my thoughts is I could go through and walk through the process of transitioning that script, or if people want to sort of work through it on their own and ask questions. Do people have a preference if they would rather me do it sort of live or work through it on their own?
In the absence of votes, it might be nice to hear you talk through your thought process and see what.
Yeah.
you get to.
Definitely. Okay. Now let's see what happens when I switch screens.
Good.
Okay, we're good. Awesome. Okay.
For folks in the room, I'm gonna update our website with the link that Elise gave. So if you need it, give me a minute and I'll put it on the website. So it'll be up there.
Okay, so so this is the script. It basically is reading in data and doing some calculations and then doing some plotting. So the first thing obviously is we do not need these anymore. We do need Terra. And I've also got natural earth for nice boundaries, and our color brewer for some color palette stuff. Okay, so the first thing we get to, get data doesn't exist. Great. So the if you are not sure so geodata, the way it works is that each type of each data source has its own because I haven't loaded it yet. There's no package called geodata. Okay. Oh, I recently updated R. That's Jesus. Surprise!
Because our studio's been hounding everyone to upgrade everything, and now it's like,
No,
Okay.
our studio doesn't upgrade your R.
that's true.
Okay, well, why is it not working?
As I asked you to go ahead and live code.
It was archived.
Geodata was archived?
That's what the grand page says. As of 4 days ago.
Yeah, I tried to install it, just says it's not available for this version of R. I'm pretty sure mine's up to date.
No, that's the problem is
That's the problem.
newest version of R doesn't have a version of geodata that's written for it.
Well, that's dumb.
Standard operating procedure though, like it got canned 4 days ago and you're.
Okay, well, here,
You're like you installed from like GitHub or
oh yeah, maybe so.
I can't imagine that it's that much different. Although maybe it'll break everything.
Yeah.
Well, now we learned don't use geodata.
Yeah.
The link to the material should be on the website now if anyone needs. So if you go to events, it'll be on the. Okay.
Okay. So we can use this. Okay.
You want to explain a minute the alternate option you're using?
Yes. So basically what I did, there is now I would say most R packages are available in their sort of quote unquote development form through GitHub. And so basically what I did, normally I would just install things through CRAN because that has the sort of stable and not buggy and like the one that like for sure works version of the package. Unfortunately, that they archived that. So CRAN now doesn't have a version of geodata that works for this newest version of R. And so what you can do is, and you can do this with not just geodata, but any package that's available through on GitHub, but isn't available on CRAN, you can use a function called in the DevTools package called install_GitHub. And then give it the sort of the name of the repository, which in this case is our spatial/geodata, and then it will install the package as it exists on GitHub. Now, the caveat being that there is no guarantee that that package works or is not buggy or anything like that. So you know, proceed with caution, but it is a way to sort of to get around the fact that things have been removed from CRAN if they're under active development. You know, if like rgdal isn't on GitHub, or it shouldn't be, or you know, but for things that are under active development, you can go to GitHub to install them. Okay, so we did that. So we can now load geodata, hopefully, and we can look up the documentation for the package. And what it can see is for each different data source, there is a different function or a different group of functions. So we are looking for world_clim. And in this case, there's multiple functions. Looks like we are looking for the global. And so instead of get data, we're going to use world_clim global. The variable we want is precipitation, so that doesn't change. The resolution is 5, that doesn't change. And then we have to specify a path, which is basically just where do we want geodata to download this. And I'm just going to put it in my current directory because I'm gonna delete it later. And then so if we do that and we can run this, and we've downloaded our data. This is just the outlines of the United States, so that shouldn't change. Oh, except I do need to install other things. More installation.
This is good because people are seeing how this actually works and it's not
Yes.
perfect. Like normal
Yeah.
people, a lot of experience go through the same thing of whoops, forgot to install this, forgot
Yep.
to install that.
Yep, that's what happens when you update your R. You have to reinstall all the packages that you thought you already had installed.
Yeah, for me, it's like every time I open up R, because I'm not a frequent user. This is really helpful.
Yep. And then we are going to load in some data. And this system file, basically what this is doing is every package comes loaded, or many packages come loaded with some example data, just to, for testing purposes. And in Raster, there was a Raster file of the R logo as a GRD. I don't remember if that's the same. So if I feel like maybe they used a different file type. Yes. So we've got the system file, instead of our logo, it's x/logo.tif. And so this is the file path of the R logo for the Terra version of that. And so we do this. Now we have wherever our package information lives, and then we can, oh, wait. I need to use not stack to change that. And now we have our logo. And this is what a spat raster looks like in R. So very similar, but it does give you a little bit more information. We also are gonna create a projection value and create precipitation color palette. So if we want to plot, create some plots of the United States that are easy to see, we're going to remove non-contiguous states just to make things easier to plot. We're going to project our, this is basically checking to see is the our logo located in the United States. Not entirely sure. I mean, you wouldn't do that, but there are times when you would want to see if your data is located in the United States. So in this case, we need to project our logo into the same CRS as our United States. So instead of project raster, that just becomes project. Known options. Oh, I don't think we need to do that. Here we go. I thought it was the same, but obviously not. Project. Oh, okay, they've renamed it. So Y is the name of the argument. For whatever reason.
Very descriptive.
Yeah. Or, yeah. But there you go. Let's see if it, no,
Do you have from and a to?
is. Let's see. It has a coordinate reference system.
I think there was other methods besides just the X and Y one.
Yeah, let's see. So, okay, for a spat raster, XY, this is for a spat vector, this is for a spat raster, this is for a spat extent, this is for a matrix. Method, what's the method?
Oh, the resampling.
Oh. This, no, that's not the issue. Cannot get output boundaries. Should be, oh. Try this. Not find.
Oh, it doesn't have the math to transition from the Cartesian coordinates to the new projection.
I have no idea how to solve that.
My guess is that because the logo is just,
It's
like,
not,
it's sort of been like co-opted
Yeah.
into like a
yeah,
spatial space, but it's not
Not
really
really
located on the
spatial.
Earth.
yeah.
It's probably just having a fit because it's saying like, oh, I don't know how to translate from this Cartesian system to,
Mhm.
a real world coordinate system.
Okay,
That's my
okay.
guess.
let's see if we can get some other, oh, here we go.
Are you trying to reproject though, or are you just trying to assign the projection?
I was trying to reproject it.
And you definitely already assigned a projection to it?
It came with one,
Yeah.
came with a Cartesian.
Hmm.
Let's try doing, so. We'll try using Luxembourg instead. Luxembourg definitely has a location.
It's not in the US.
Well,
We'll find out.
we'll find out whether Luxembourg
We'll
is in the
find
US
out.
or not.
We could still project it to the US coordinate system. It'll just be really wacky looking.
Oh. Okay. See,
Probably won't need that sampling method
okay, that's true.
because it's vector.
Here we go. Okay. And then this, we don't need to do any, we don't need to deal with this. All we need to do is use the is related. And that is related, and then relation. Is this Oh, it's doing it by, what's it called? Polygon. So if we wanna say,
So if you were to say is related, vect USA to vect USA, you would get 50 trues. Are
no,
those, I guess I'm asking, are those falses coming from Luxembourg?
yes.
Show us what happened.
Yes.
USA and USA.
Yeah, I might not like it because it's the same thing, but
Just, yeah.
I think it cares.
No.
you never know.
So yeah,
USA is in USA, and then there's however many
yeah.
provinces or
yeah.
whatever in Luxembourg.
Yeah. Exactly. So, um, so we have this, and then we do except it should be Luxembourg. But Luxembourg is not in the United States.
I think I know the fix to the original problem, though.
Oh, yeah.
I think that you should just reassign the projection with CRS, not try to project.
Mm,
Go.
Yeah.
I was just looking at the code and didn't set the projection at any point. So if it came in with Cartesian, you should just tell it that's not right and assign it the Alberts.
that makes sense. Well, that works. Let's see. So we can. Oh,
How is it already?
let's see. We can do. Okay. Terra documentation. This bigger. Oh, expanse? Okay, so expanse would give us the area of everything. What if we just want the area?
Would you use, if you only wanted the area of like one of, like
Yeah.
a state or something, like the area of California, wouldn't you use expanse and then just subset it in the
Yeah,
expanse
you
function?
could do that. That would work. So if we do.
Oh, I'm just kidding.
Oh, so it does it.
This is for each polygon if there are multiple.
There we go. So. So this is, let's see. What's the unit on this? Oh, it doesn't say.
4326 degrees.
What do you mean?
Oh, if the projection is 4326.
Units are degrees.
Oh, yeah. But this can't be degrees.
I would assume square kilometers, but that's because it's in Europe.
It's hard to know
I don't know how that works.
Typically, at least traditionally in Raster, and I don't know if it's carried over to Terra, a lot of things where if it was in 4326, it would default to knowing that and specifically calculate it.
I think it,
It's
it
meters.
says that it defaulted to meters.
Meters.
Yeah.
Meters squared.
That makes more sense for that number.
Yeah. Yeah, I was like, that's way too big to be.
Right,
Degrees.
there's not that many degrees and.
Yep. Okay. So if we want to project USA to have a more nice projection, we can again use the project function. Oh. Jeez. A second. And then if we want the area of the polygons, again, we can use expanse. And this is going to give us, yeah. Sum this up if we want to compare area.
On that one.
Oh, there we go. Okay. So we can do, you know, the basics of what you could do in Raster, with some minor name changes. Again, interacting with the world clim data. Again, there's some name changes. So and layer. So we know there are 12. We want to know what the range of precipitation is over the world. Get values becomes values. Actually taking a second. So 257 centimeters of rain. That's a lot of rain. If we want to look at precipitation over, what's it called? The United States, we can use the project. And we should not say that that's the CRS. Whoops, sorry, forgot a step. Okay, I think crop and mask have stayed the same. Yep. And then can do this to project everything into Albers. If we are Americans and we think about things in inches, we can convert our precipitation to inches. And so this, you know, raster math, this, you know, multiplies the entire raster by every layer by that value. And if we want to calculate seasonality, oh, this doesn't exist. How did I do that? Forgotten. Oh, yep. Oh God, I'm not gonna be able to remember how to do that. Okay. So I'm gonna go through this. So previously, There are some times when things have gone away. See, I don't know if you guys have ever used the CV function in Raster. It calculates the coefficient of variation by cell. That function, for whatever reason, no longer exists in Terra, but we can use the app function to replicate it. So we have a function we want to calculate for each cell. So that's the app function. The input x, which is the our input raster, and then we need to calculate the coefficient of variation. Like apply or lapply, we're going to use the function to create a little anonymous function here. That is going to be, it's this standard deviation, which still exists, hopefully. Yeah, standard deviation of our raster. Actually, let's change that to R. We know that this is a raster. And then to remove any NAs. And then divide by the mean of our raster. If you did this before you put the mask on, you wouldn't need to include this NA to RM equals true, but that's life. And then we multiply by 100. And so this is equivalent to CV in raster.
So CV went away.
CV
so
went
now
away.
You have to write your own function that mimics what it would have done for you automatically.
Yes. I think that CV is the only example that I've seen where that's the case, where something has gone away and you have to sort of recreate it on your own. Thankfully, the coefficient of variation is not hard to calculate. And so now we can plot seasonality. Let's see. Not so you can see it's hard to see. Well, looks very similar to Raster. You can also create plots with multiple multiple plots. So say we want to look at precipitation in different seasons. Something that if you grow plants in California, you learn that it's very different growing plants when it doesn't rain for the entire summer. So here's another function. So stack apply is basically almost directly transition to tap. They just renamed it to sort of be in the same naming convention as app, tap, lap, tap, all of those. So in this case, what this is doing is basically we're grouping the months into spring, summer, fall, and winter. We're gonna give the function that grouping. I don't remember if they changed the argument name. Index, okay. Index, not indices. And then we just want the total. And so this will give us, now we have a spat raster with 4 layers, 1 for each of the seasons. I'm going to set anything that's greater than 30 to 30 to make it easier to plot. And then let's see. There's a slick way to do this. Oh. You can also use classify. So let's see. This still works. Why it's taking so long.
Blame Zoom. We always blame Zoom.
Yep. Okay.
That's very cool.
You can also use panel to get it so that these have one scale, so you don't have the legend appear each time. And then say we can also, average, say we want to, look at, averaging things by state. Another thing you might want to do. The extract function, I believe, mostly stayed the same. But the question is, CF is no longer necessary.
I ask, this is a dumb question, but I will ask. For each thing you're encountering,
Yes.
you're looking up the help.
Yes.
And when you look up the help, that is the current function in Terra that you're getting the help for.
Yes.
So then to know what's changed, are you appear to be relying on your vast experience to just say, oh, this is what it used to be and this is what looks different?
So when I first transitioned the script, what I did is I ran everything in just as is and waited till I got errors.
Okay.
And then it was like, oh, this needs to change. Oh, this needs to change. Oh, this needs to change. And because I transitioned the script once, I can sort of remember like, oh yeah, I remember. I think this was the same. There is actually, I'm gonna pull up one of the sort of help things. Let's go here. There's there is a, let's see if I can find it. There's a somewhere there is a place where it lists all of the things that have changed.
Oh, okay.
Changed behavior. So if you go to the reference and then Terra package, it will show you things that have changed about this, like extract. Here we go. By default, Terra returns a matrix. Raster returns a list, so that's something we would have to deal with.
Okay, okay.
I will say, and then, oh, here's new method name. So these are the name changes. And then there's also the name didn't change, but something about the function changed. So I would use, and this was what I did. I used these two sections as like, assume it's the same unless it shows up in these two sections, or you get an error. Because like I said before, the goal with Terra was not to reinvent the wheel. The goal was to just like make things easier to maintain and more useful and more sensible.
Yeah. So this looks like if this looks like kind of like the Holy Grail. You're not the Holy Grail, the Rosetta Stone.
Yes,
for
this
you,
is
right?
the Rosetta Stone.
So if you're in our studio, is there a way to look up, like when you do the help function, is there a way to ask it for the raster help?
Yeah.
So that you can. just
Yeah,
kind of
if
see
you-
Side by side?
So if you,
Sorry, this is my art and experience.
I'm sure there's plenty of other people
Oh,
that
yeah.
would love to know this.
so if you do this, if you do question mark and then the name of the function, you will get a list of all of the locations where that function name shows up. So I clicked on Terra. I was wanting to see what the Terra documentation is, but you can also click on Raster to see how was it in Raster.
The list it gives you is just packages you've
This is, oh yes,
installed and loaded,
this
right?
is just packages you've installed and loaded. So you have to load the package. So if you don't load Raster, you won't be able to see the documentation.
Or you can go read this online.
Yes.
All these are online, and so you can have multiple tabs, one with one and one with the other.
That is true.
So between your Rosetta Stone, the errors, and the side-by-side thing, you can eventually pick apart like
Yes.
what actually you need. Okay,
Yes.
cool.
And
Thank you.
even in Spat Raster, like you can scroll down and see what the arguments mean if you like already kind of know like, oh, this is the
Yeah.
I need you like you know that you need an X and a Y and you
Yeah.
can scroll down and see what those
Yeah.
what it's expecting, I guess.
Yeah. If you go down to the arguments section, it'll tell you, oh, that's the Raster version. Yeah, it'll tell you, oh, the first one, it expects it to be a spat raster or a spat vector, and then the second one needs to be a spat vector.
I'm so dumb. I'm just like, it works, don't touch it. So I probably would have to look at both.
I appreciate that sidebar. Thank you.
Yeah, definitely. Yeah, it can be difficult to remember how much knowledge is sort of residual knowledge from having done this for a while. So yeah, so in this case, so what it said previously is, in the help, it said extract by default, Terra returns a matrix, whereas Raster returns a list. And I believe that df equals true was to compensate, to tell it not to return a list, to return a data frame. So if we do this, and let's make sure that na.rm is still, we'll assume that that's allowed. And then if we get an error, see.
Hard to know because that dot at the end means all sorts of things.
Yep.
Fast.
Exactly. Yeah, I think the na.rm is getting passed to the mean function, so that should work. And then
It was really validating having someone else be like, and then we're just gonna see what happens.
I mean, and honestly, this is so much of what I do in R, and so much of what I try to tell people to do is just like try things. You can't, well, maybe if you really try, but most likely you're not gonna break your computer from inside our studio. Like you would really have to work at it. And so there's not really much risk with trying things.
Yeah, worst case scenario is the computer hangs or
Yeah, you have to
Like-
restart.
get the little message with the little bomb thing that's like, I died and restart.
Yep.
Don't overwrite your data and you're fine.
Yeah, that's the no, be careful when you write stuff. So now we have this USA precip 0 object. Let's see what kind of object it is. So it's a data frame, so we don't need to convert it to a data frame, and then we can just give it, so it has all of these weird names, which we don't want, so we're just gonna rename it with the normal names. And then we are going to add it to our USA albers. And now we have you know, for each state, we have the, you know, the state information and also the precipitation. I am going to go over to this section because I do want to show you a little bit of what you can do with ggplot, but I could not live code this.
Fair enough.
So I want to, so there's, well, first, are people familiar with ggplot? Somewhat. Okay, great. So, one of the sort of weird things about ggplot is it likes to use functions to label its axes. So one of the things I did here is I created a function that only printed out labels if it was a multiple of 5. Because when you have labeling, things can get a little bit crowded. Anyway, so we have this. We created our precipitation. So one challenge with working with ggplot with spat rasters and spat vectors is that ggplot depends on long data. So basically it wants you to have, if you are using what's called faceting, is basically like you have little subplots. It wants you to have a separate polygon for each one of those subplots. And so end up with kind of a large data set to do the plotting, which is like, if your data set's not that big, it's not that big of a deal. But the challenge is that Terra doesn't have any functions that sort of allow you to easily create this sort of long multi-polygon duplicated data. So because of that, I use the merge function to basically replicate my the polygons. Okay, so what this is in theory going to do is, oh, I do have to load GG. And I do have to load ggplot too. Okay. Oh, and I need to load tidy Terra. And I probably need to install it too. Okay. So that's these geom spat raster and geom spat vector. Those functions come from tidy, which is a separate, I forgot to create that labeling function as well. Oh, did I not? Oh. Oh, there's multiple. Didn't I just run that? Let's see. Okay. Oh, X2. Oh, here we go. There we go. Yeah. Labeling in ggplot is incredibly customizable, but also incredibly obtuse. Again. Nope. Invalid graphics.
There's a good one.
Oh, well, I mean, happens all the time in R where
Yeah.
the plot window gets strange for some reason.
Yeah. So let's see if we. Okay, well. Unfortunately,
It exists. It's
it
very-
exists. You can see that it's labeled and everything.
Yeah.
Oh, here we go.
I was about to ask, there's a trick to get it to pop it into its own window, right?
Yeah, here we go.
That's the
There we go.
zero.
Zoom. Oh, except it's even worse. So then you can sort of, you know, have things that are maybe slightly more visually appealing. But then, you know, the downside is you do have to have, you know, store the polygons of the United States 4 times instead of once. And let's see.
I feel
Yeah.
like there's other ways to make that. Have you ever heard of cow plot? It might not work anymore though. so I'm not
Sounds
gonna,
familiar, but I haven't used it.
there might be other ways. Anyways,
Yeah,
it's like a whole deal.
definitely other ways
Yeah.
of making multiple plots on one thing. I have heard of cowplot. I haven't.
It might not work anymore, so don't.
Okay.
Plotting's like a whole other thing. We could talk about plotting all day.
Key map was,
Yeah.
T-map is the sort of the fancy one, right? Like you can click on it and it does pop
Yeah,
up.
it makes like interactive stuff.
Yeah.
but it
So-
can also do the multiples like we're looking at right now.
Well, someone wrote an introduction to cow plot in January, so I think it's still a
Am I-
thing.
Yeah.
I don't know. Plotting's like its own thing. Like half the
Yeah.
time I just make a little function and then just apply it across the things I need.
My favorite thing to do is make something really ugly in R that has the stuff I need,
Yeah.
export it as a PDF, bring it into Inkscape, and then make it look good there.
I'm all about base plot. If I can base plot it, I will.
Yeah, I'm a big fan of base plot, just to be like,
Yep.
is this what I think it looks like floating
Yep.
in space?
Okay. Okay, so here's this is plet. So so as you can, you know, I didn't well, this is what happens. This is very strange. Something is very wrong.
It's it's not matched up.
Yep.
I was like, it looks fine, but then it doesn't match the base layer.
So anything that uses leaflet is gonna plot in spherical Mercator.
Yeah, so maybe.
Oh, so I have to change it back to spherical Mercator. Yeah, I don't think I.
would assume that that would be built into the function to transform into that, knowing that that's what leaflet needs.
Maybe not.
Oh, but this isn't a pop-up window? Regular.
This is in the Zoom. I wonder if I.
Send it to Albert?
Yeah, but the other problem that can happen is that once it plots,
Yeah,
the window is sort of set, and if you change the size of it,
yeah, it can
graphics
get
don't
messed
update
up.
properly. Like it gets very confused about the
It's
two
definitely wrong.
That's a projection issue.
Yeah,
It's like, what's the projection of your data?
I think Albers, but I could be wrong. Yeah. So obviously, my experience with the plet function has been that it's fine, but there are better ways of doing interactive plots, as exhibited by this. So if you're really going all in on interactive plots, I would not. I would use plet like if you need to zoom in on something to like see like in like base plot. Like I just need to see to make sure this data looks correct.
And I think that's really what the interactive plotting in R is good for, is
Yeah.
like, I just need to see, did I subset this right? Is it doing what I thought it did? It's not
Yeah.
really for making things for prime time,
Yeah,
like, you wouldn't put
Exactly.
this into a journal article or anything like that.
Great. Do people have questions?
I have what I probably could have even asked way earlier is like, so I don't really use rasters. I'm like vectors and points and stuff like
Yeah.
that. And the only reason I'm like, what is Terra is because the way that I was loading my data in just stopped working and the
Mhm.
internet's like,
Yeah.
use Terra instead. Do I need to use Terra? I'm mostly using SP. I don't like SF.
Well,
Is it just like,
so shouldn't be using SP.
all right, well, there we go.
Because
Yeah.
SP is going away.
Okay,
If
well,
you, I mean, it's going away. So it's going away slower than rgdal, but it is still going away. And if you don't like SF, then you should use Terra. You should use the vector functionality in Terra.
and I guess since like an SP where you have to be like spatial points data frame, spatial polygons data frame. I guess that kind of removes that
Yes.
things.
Yes.
I mean-
Glad I stayed.
I mostly work with SF.
Mhm.
And I didn't find the transition from SP to be that difficult. It's just a matter of like remembering what you're doing or like Googling for,
Yeah, I don't know why.
in SF instead.
I don't know why I never got into SF. I think I just like I made it work in SP and I wanted it to work.
But yes, whatever you decide, continuing to use SP is not a good.
Just overall bad idea. Okay.
So the author of rgdal retired. That's part of why rgdal, aside from the technology was moving on, needed to be retired. He was also the author of SP, but the author of SF is currently maintaining SP until everybody can transition off, and they've already set the date for its retirement.
All right.
So it's SP is basically only in use so that other R developers can transition away from it.
Okay, that makes sense.
It's a tricky time to be doing R for
Yeah.
spatial people because a lot of stuff is changing and transitioning. So,
Yeah.
What do they do with like I don't want to do we can if there's more questions, but like what do they do with like really old like I published a paper where everything was in SP and it's got like a GitHub, it's got like a model.
You can install an old version of R.
Okay,
You
okay.
can pull from the archive an old version of SP. So when this is a great thing about reproducibility. When you go to publish a paper, you need to actually make a list of the specific versions of the core packages you used. So if somebody wanted to recreate that environment, they can go to the archives and get it.
Yeah, it clearly was not a geospatial paper because I think I would have hoped an editor would have caught that because I definitely didn't do that. But
Well, I mean, if
on the journal.
I don't think
Yeah.
most journals, except for journals that are software.
I would have I don't know, I would have
The Journal of Statistical Software, which is where people publish R packages, they would have caught that.
Yeah.
But no other journal. is
Really?
likely to.
I feel like that would have been like, you know.
But I'm just saying from experience of what I teach scientists to make reproducible examples is you need to make a file that lists the packages and versions. And there is a package in R to help you do that.
Well, it's way too late now. It's been years.
Right.
I'm over it.
Future.
I was like they can get rid of it. But yeah, no, that's important.
Those sort of
Yeah.
future things. And the concept exists in all programming languages, like this idea of making a way to reproduce a container that had all the same stuff.
Yeah. Interesting.
Your data too is kind of one of those things. I mean, and if they take it down, there's not much, but like save a version of whatever. My master that finished less than 2 years ago, and they've updated the data set, and they just put up version 2 and took away version 1. It's just not there, so none of my scripts work. But fortunately, I had a copy. But it's the same thing. Like it feels permanent while you're doing it, and it's just not. Nothing's permanent.
I mean, this all is about like reproducibility and,
Yeah.
you know, Data Lab actually does whole workshops, but they're unfortunately not geared towards spatial stuff. So, you know, that might be something we want to do in the future is
Yeah.
figure out, but that's also a hard thing to get people to come to. It's like cartography and data management. People talk about needing it and don't come to the workshop.
Remember, it's called PackRat.
Hackrat. All right. Yeah, because I'm like
It helps you.
Building
It helps you make
things.
an archive. So you can even make an archive of the R packages you used at the time if you wanted to save it.
You have like the code that runs those packages.
It's kind of like environments in Python. You can just switch between them. And so like you open if you use projects in RStudio, you can actually have it say that this is like a PackRat one, and then it'll actually store a separate copy of the packages just for that R project. And it won't use any of your system ones.
cool. That's good to know.
Come for the spatial data, stay for the environment management.
Totally true.
Any more questions?
Nobody's posting anything online,
Okay,
so I guess we're good.
great.
Well, thank you, Elise. This was awesome, and I've learned things, and I expected to learn stuff, but I did. And
It's always a good thing.
Yeah. Because I work with this stuff pretty frequently,
Yeah,
but still I learned things like I didn't know about plet, so that's
Mhm.
exciting.
Yeah, yeah, it's and also as a note, I mean, Terra is still very much under active development. And so if you find problems, you can put in issues on GitHub. So like while I was originally doing this thing, I was part of the reason I didn't include plet in the sort of main part was because I was running into an issue with plet and it wasn't plotting and I was like, I just can't deal with it. So I cut that part out, but then I reported the issue on GitHub and it got fixed later. So
Very nice talk. Thank you.